This conference will now be recorded.
Good morning, student. So this is the third chapter, and this is the last, we can say. We have to see what is the evaporation, right? So if I will talk about the evaporation. So first of all, why we are talking about the evaporation? Because the evaporation. Evaporation is what and why we are to talking about this. So the definition of evaporation means what? The transfer of liquid from into gas, right? The transfer of liquid into gas. Suppose this is the water body somewhere here. This is water body, right? Any lake may be here or the river may be there. So what happens because of radiation? Sun radiation is there, right? And this water becomes in the form of gas, or it converts from liquid to gas. Then this process is called as the evaporation. Now the definition is clear. Now next is why we require to understand this evaporation. So the studies shows that the tons of water, we can say the tons of water converts tons of water converts into the gases. So what happens? Suppose any city, any lake is there, right? Suppose here lake is there, and the quantity of water, say 20 million meter cube, right? 20 million meter cube of water is there. So for example, every day suppose zero point 0.5 million meter cube in the summer season is water is going, right? So just if it is in one day, this amount of evaporation is there. So this 20 million meter cube, how much time will be required? That may be finished within 40 days, right? If we'll multiply it 40 by 0.5 means 20 million meter cube will be finished within 40 days. Then we should know about this evaporation. Next is there, suppose any hydropower plant we want to establish, right? We want to construct any power plant. Suppose this is a dam, right? And here water is there, right? And so whatever the store we are storing the water, so this water will also require for generating the power, right? So this water will be supplied through some pipeline somewhere, right? Suppose this through this pipeline, this whole water, this will come through pipeline, and through this pipe, this will, we can say, through this water, the power will be generated, right? So we should know what is the exact quantity of water so that we can construct any power plant, right? Hydropower plant, I mean, right? Hydropower plant, the power plant which runs through power through water, then we say that is the hydropower plant. So we should know the how much quantity of water will be available for the whole year, right? For 1 year, and where it is coming from, what is the source. So based on that, we plan everything. Suppose the farmer is there. So we have to supply the water also to their farmers, right? So that cultivation of crops may be there. Suppose they have the plot of and the crops are there. So we have to fulfill the requirement of the farmers. So in that case, we should know what is the quantity of water is evaporating. So we have already seen that in the hydrologic cycle, where when rainfall occurs, some of the losses occur and the runoff occurs, right? Suppose this is our hydrological cycle. We have already seen this is the river, right? So when rainfall occurs, some quantity of water goes into the soil, that is called as infiltration. Some of the quantities flow over the surface, that is called as runoff. And some of the quantity which evaporate, right? That is called as evaporation. So obviously, this evaporation is also one of, and infiltration is the loss. And whatever the suppose rainfall came, suppose 10 centimeter, right? Out of that 10 centimeter, 5 centimeter quantity of water is just losses. And remaining, suppose this is the catchment, right? Water is coming through rainfall. Once it will collect in the river and it will come at this point. And at this point, we will measure the depth of water, suppose for 10 centimeter rainfall depth. So depth is suppose we are achieving say 5 centimeter. 5 centimeter means 5 centimeter after if I will put the rainfall that is 10 centimeter runoff, say this is 5 centimeter means what? 10 minus 5 means the losses is what? The losses is equal to 5, right? If I will put the value 10 minus losses is equal to runoff is also 5, right? So this loss will come here and this 5 will come here. So it will become what? 10 minus 5 equal to what? 10 minus 5 equal to 5 centimeter. This 5 centimeter is what loss. So within this 5 centimeter, if again we know that what is the infiltration, so remaining one is what? Suppose infiltration is 3 centimeter. So remaining is what? 2 centimeter depth of rainfall is evaporating, right? Evaporation. So for that, we should understand what is evaporation, how it is calculated, how we will come to know the evaporation. So in that, for this, we understand what is evaporation. Now, interception loss. Interception loss is nothing but that is due to the surface vegetation held by the plant leaves. For example, rainfall occurred, right? And here the number of trees are there, right? So some quantity of water will be there on the trees, right? So that is what that is intercepted by the tree or vegetation. There may be some grasses may be there, right? That will also carry. So that will be held by the plant and plant leaves. That is called as interception, and that losses occurs. So that loss is nothing but the interception. Now, evaporation is what from water surface. That water evaporation may be from reservoir, maybe lakes, or ponds, river, or any channels, right? And also from the soil surface. Suppose this is the soil surface, right? And this moisture is there, right? So that will be also evaporated. And when the groundwater table is very nearer. So this soil will be when it will be moist when the below the water this soil below this soil surface or ground surface. Suppose water table is very nearer. Suppose I say that this is a 5 meter, right? So in that case, this soil will be moisture, and the soil will have some moisture, and this moisture will go into the atmosphere. Similarly, transpiration means what? Transpiration is evaporation from plant leaves. What the same thing. Whatever the water comes and it will be somewhere here. And when the evaporation will be there, this water will go again into the atmosphere. So this is called as the transpiration, means the evaporation from the plants. Now, evapotranspiration is what? Some see what happens. Some quantity of water is in the soil, and some quantity of water is on the surface of the leaves. Both will go into the atmosphere, right? That when both will go into the atmosphere, then that is called as evapotranspiration. Evapotranspiration, right? So that is called as evapotranspiration. Now, evaporation is clear. Evapotranspiration is clear to you. Then infiltration we already know. And so here, some see what happens. Suppose this is the river. So rainfall occurred here, right? So rainfall occurred here. So what happens? The whole water will come into the river. So that is rainfall is there. That is incoming. Some surface runoff is also there. That is also incoming. Right? Some from water table, some water table, or we can say base flow. Right? We know this base flow. What is base flow? Water is again also coming into the river. So this is what this is inflow, but some quantity of water is going out. That is called as the losses or leakages, right? So groundwater movement from one basin to another or into the sea, right? So that may go, this water may go somewhere in other basin, means in some other places over the earth, or this water may also go into the sea, right? This is the meaning actually. Now, how we measure this water interception loss? That is already cleared. The precipitation means the rainfall which is occurring is intercepted by foliage or plant leaves and buildings and return to the atmosphere without touching the ground surface is called as interception loss. So effective rainfall is equal to what? Rainfall minus interception loss. That is called as the effective rainfall. Now, how evaporation is calculated? So evaporation from free water surface and soil are of great importance in hydrological studies. There is one pan. So this pan means what? Pan is just like instrument, right? In which the water is kept, and once the sun will be there, so every day for every day what will happen? This water will be kept, and once the sun will be there, so what will happen? This water level will decrease. Maybe some it will come at this level. So this much depth of water is what? This depth of water is losses. So this pan is what happened. Suppose there is some, here I will come. So here suppose there is a river or pond is there or lake is there. Just near the river this pan is kept, right? And whatever the quantity of water will be, whatever the quantity of water will be evaporated, right? It is assumed that means this pan evaporation represents the evaporation loss from the pond. But obviously this pan is very, means maybe it may be 1.2 meter diameter, but this lake may be 20 kilometer, right? Or 30 20 kilometers square or 10 kilometers square, right? So but the evaporation from this lake and from pan is different, right? So just this is kept near the river, and whatever the pan is, whatever the evaporation is there, suppose this is the evaporation, it is noted down, and we have some coefficient, like the formula is like lake is equal to pan coefficient, evaporation from pan, or we can say evaporation of lake is equal to pan coefficient multiplied by the evaporation from pan. We will see in detail in the next coming slides. So pan is just an instrument which is used to measure the evaporation loss. So some different types of pans are used. Here one of the pan is introduced, and this is in India they suggested some dimensions, and those dimensions are used in India. So here they said that this uh, evaporation is measured at 8:30 a.m. and 17.30 means at 5:30 we can say p.m. at as per the Indian Standard Time is measured. Similarly, there are some other type of pans, but just you remember this. Only pan is the instrument. Now next is, see that this formula pan coefficient is equal to what? Lake evaporation is equal to what I told you. lake evaporation is equal to, see, this pan evaporation will come here, and what will happen? This will lake evaporation will be equal to pan evaporation multiplied by pan coefficient, right? See, this is one of the, we can say, diagram is given. This is what, this is pan. So here water is kept here, and whatever the quantity of water, suppose this quantity of water is evaporated, so that will be noted down, right? So that is one of the instrument to may use it, which is used to measure the evaporation. So here there are some factors which affect the pan evaporation, right? So some factors affecting the pan evaporation is what? First is surface area. And see, evaporation loss is represented as E suffix L, means evaporation loss. So first factor which affects the evaporation is what? Surface area. Surface area means what? Suppose this is the small lake and this is very big lake, right? This is having area. This is also, I say, this is area, right? So when sun will be there, so what will happen? Water will evaporate, right? Water will evaporate. So this evaporation loss is represented as L, EL suffix, E suffix L. So as this area will be less, area is less, and here area is very more, we can say very big area. So area is more, area is less. So as the area will be more, the evaporation loss will be more. So we can say that this area is proportional to evaporation loss. As the area will be more, the evaporation loss will be more. This is one of the factor. That's why here it is given as evaporation loss. Evaporation loss is proportional to with the area. Now the second is the temperature. Second factor is what? Temperature. Temperature means, suppose there is a summer season. So what will happen? This evaporation loss will be more. It will be more, right? When winter season will be there, this evaporation loss will be less, right? So we can say that the temperature is also plays a very important role, and it is proportional to the evaporation loss. Temperature is proportional to evaporation loss. Next is vapor pressure. Vapor pressure means what? See, this is our atmosphere, and within that atmosphere, suppose there is some, we just assume that there is a one water tank, or there is the, yes, very big water body, or just you assume that this is a big water body is there. And what happens? This this will convert into evaporation. Water will convert and it will evaporate and it will form some like some vapor, right? So what happens? See, this vapor is going into the atmosphere, right? Right? This is going into the atmosphere. So atmosphere is also having its own level. Like suppose a person is there, right? A person is there and he is having a capacity of taking the food of, say, uh, 2000 calories, right? 2000 calories. So after 2000 calories, he cannot accept or she cannot accept after 2000 calories. Or another example is, suppose you have a mobile phone and you have a hard disk, we can say capacity of mobile is say 32 GB, right? So this mobile cannot accept more than 32 GB. Similarly, our atmosphere is also having the vapor pressure, and this vapor pressure have some saturation level, right? If it will be more, so after that what will happen? Evaporation will not be more, right? A level will come when this evaporation will be less. So what is this E sat minus E actual? E sat means saturation evaporation level, evaporation saturation we can say, and E actual means actual evaporation. So when we take the difference of this, what is actual, what is saturation level, and what is actual, right? Saturation and actual. See, 32 GB is we can say actual, and you cannot accept more than 32 GB, right? See, if your mobile is having 32 GB space and it is already occupied 32 GB means this will not work properly. And if it will be say very less, say 1 GB only, it means what? It means what? Vapor pressure will be less and evaporation will be more. So as the difference will be less, evaporation will be less, right? Just 1 minute, student. Okay. Now, so what I told you, so vapor pressure is what E saturation minus E actual, right? As it will be more, this the difference of this will be more, the evaporation will be more, right? If it is less, the evaporation will be less. Now next is there is another term we can say that is another parameter or that affects the evaporation, and that is what wind speed. Wind speed means what I told you. Suppose this is the water body, there was some vapor. So whatever the water was taken from this water body through the radiation, this is converted into vapor. Now, if here the vapor will be there, so if after if it will be means this vapor will be exactly at this same point, what will happen? This moisture will not go into the atmosphere, and this evaporation will be less. So what happens when wind comes? This wind comes. What happens? This vapor, whatever the vapor is available over the water body, they will not be here. They will go somewhere here. Right? So again, this space will become vacant, and again the evaporation loss will be there. But what happens if I will show you in x and y axis? So here this evaporation loss and this wind. So as the wind will blow, and what will happen? This wind will take this evaporation somewhere here, and water evaporation will be there. But one point will come. One point will come. This whole atmosphere will be filled with this vapor, and it will become constant. So here the same thing is given. Even if this evaporation loss is continuously occurring as this wind is increasing, but after what, it is becoming at some constant, it is going at some constant level. After that, it is not evaporation evaporating, right? So this is the, it means what? That is also wind is also one of the factor which affect the evaporation, right? Now next is humidity. Humidity means what? We know that this is generally, this humidity occurs nearby the sea area. Suppose Muscat is there, right? This Muscat is nearby the sea. Suppose this is Muscat city and here it is the sea, right? This is our Muscat city and nearby is, this is the sea. Or Sohar is there, right? Sohar city is there. So near the Sohar there is a sea. So in that region, what will happen? There may be some, we can say, humidity will be there. Humidity means what? The moisture or the water will be in the atmosphere. So in that case, what will happen? In that area, this evaporation will be less. So that's why here this humidity is inversely proportional to evaporation loss. Next is soluble salt. Soluble salt means, suppose this is the sea water, right? So here this seawater is having salt, right? So because of presence of soluble salt, this evaporation loss is we can say it becomes small, right? Or we can say it is inversely proportional to the evaporation loss. So salt or soluble salt is, if it is present in the water, then evaporation loss will be less. Next is depth of water body. Suppose some river is there, right? The same thing here. If, but again there are the two conditions: depth of water and depth of water. Suppose this is depth. This is the depth of water. This is, we can say, shallow depth. Shallow depth means we say small depth, and we can say big depth or longer depth, or very deep means this is very deep. So this shallow and deep, again they place, this depth plays very important role. But here is again one condition, that if summer season is there, then what happens? If this is summer season and this depth is more, what will happen? Some top surfaces will be hot, right? The remaining water will be something, temperature will be small, right? So in that case, what will happen? The evaporation loss will be small, right? In the depth, when depth is more, but when shallow depth is there, the whole water will become hot the early, and this evaporation will be there. But in the same time, what happens? But if suppose the winter season is there, so what will happen? So in this case, what will happen? See, this winter season means this depth is small. So what will happen? This, the whole body which is having shallow depth, this will become very cold early. It will become cold in a very short time, short period of time. But this depth is very high, so this will take some time to cool the water. So what will happen in that, between that time, the sun will be there, and this sun will take the water, or the moisture will go into the atmosphere because of sun, and this, because of this depth is very high, it will take time to cool, and before cooling, this sun will, this sun will, uh, we can say, evaporation will be there, right? Because of sun. So here it will take more time to cool, and then sun will evaporate the water, right? So this is the two cases, we can say, summer and winter season, and the depth of plays an important role. Now there are some methods for reducing the evaporation. So before going into that, we will see what are some methods to calculate the evaporation. Uh, So some of the method means one of the method is the analytical method. The analytical method means it is there are again three methods or two methods, we can say three methods generally. We will see only it once. One of the method is water budget method. Water budget method means suppose this is our river. So what will happen in the water budget method? Some quantity of water will come into the this is the river, right? Some quantity of water will come through runoff, so that is called as surface inflow, right? Then some quantity of water will come through water we can say base flow or through water table into the river. This is our river. Some quantity of water is coming from ground. That is called as say ground inflow, right? GIF. So this is only the two sources where the water is coming. But what happens? Another is what precipitation is there. Precipitation, or we can say rainfall, right? Rainfall is there through which water is coming. No, that is precipitation. Or now some quantity of water is going outside. Suppose there is the water which is going out from the river, right? This is called as leakage, or that is called as also ground outflow, right? Similarly, what will happen? Some quantity of water will be used by the persons, by the people. That is called as surface outflow, right? Similarly, some quantity of water will be evaporated, right? So what will happen? See, if water which is coming incoming is there and some outgoing is there, so another will be what? There will be some change in the storage level, right? There will be change in the storage level. Uh, okay, we will see in the next lecture. I will. What is this? Because I am feeling facing some problem